choosing the right RAID layout for your hard drives. So you've selected the SAN, you've purchased it, you've racked it, you've plugged it in, you shoved all 48 drives into it. Now what? It's time to configure the RAID. What is a RAID? A RAID is how we can group a bunch of hard drives together and make them show up to the operating system as one gigantic hard drive. Let's start with the most fundamental example of this by picking on just this first stack of 4 hard drives here. I'm going to draw them out like this with just 4 squares, and each one of these will represent the hard drive. Now let's pretend we have, say, a Word document that we want to write to these 4 hard drives. And let's say in the most simple form, its binary is just 4 bits of 0, 1, 1, 0. In RAID 0, I'm just going to go ahead and write it out here so we know what we're talking about. In RAID 0 would take the 4 hard drives and pool them all together with no backup plan in place. For instance, if each of these hard drives was 1 terabyte, it would show up to the operating system as one 4 terabyte hard drive. So we're going to go ahead and pool these all together. And when our Word document comes in to be written to these hard drives, it will be written across each of these drives. This is called striping. Now this is awesome because it gives a huge performance benefit. The drive only has to write 1 bit in this case, and whenever we call the file back, it only reads 1 bit. But what's the problem? If any one of these drives dies, we lose the whole file. That is no good. In other words, you're going to get a performance increase for using RAID 0, but you should never use it in a production environment because it's just too risky. All right, let's move on to RAID 1. RAID 1 does something similar where it lets us write to one disk, but then it makes a copy of that data to all of the other disks. So instead of showing a pool of drives, we basically only see the one drive, and what's happening underneath the scene is you're going to get a copy of all the data on each of the disks. So if one of these disks dies, it just rolls to the next one. Super cool for redundancy, but it's kind of a waste if you have more than 2 drives. Enter the hybrid of the two, RAID 10, or sometimes written as RAID 1 plus 0. What it does is this, is it kind of pools the drives together, but then splits them in half. So in this case, if we were writing our file to this drive, first what it would do is it would split the file in half. So 0 and 1 would go over here, and 1 and 0 would go over here. But then from there, it would write the 0 and 1, and then a copy of the 0 and 1 on each of this group, and then 1 and 0 here, and then a copy of that 1 and 0 here. So you get the performance benefit of splitting up the file a little bit. There's less to write and less to read, but then you also get a redundancy benefit that if you lost one of these drives, the other one would be able to step in and take its place in the event that there's a hardware failure. It also gives you time to come in and put in a new replacement drive. Another big benefit of this layout is when you lose one of these drives and you come in and you replace that drive, the time to restore that drive back is much, much quicker because it's just copying this data right here in this place. One of the cons to this layout, though, is they advertise it as you can lose up to 2 drives. You see, if we lost this drive here, we then couldn't lose this drive, but we could lose one over here in this secondary group, which is kind of nice. Now, one of the most common implementations of RAID, though, is something called RAID 5 or RAID 6, which we're going to talk a little bit about in a second. The way RAID 5 works is it allows us to use, in this case, 3 of the drives to spread the data out, and then the 5th drive keeps track of what was on each drive in case one of them dies. Check it out. This is going to be an oversimplified version of how it works, but it's going to work like this. In this case, we have 0, 1, 1, 0. So it would write 0, 1, 1, and 0 on this drive. And in this case, what this last disk does is it basically sums all of these things up. You see 0 plus 1 plus 1 plus 0 equals 2. So if one of these drives dies, it can then say, oh, well, we lost this, but we can use algebra to figure out what was in its place, and then this drive would step in and take over for that drive. This is awesome because it allows us to maximize the amount of disk space that we can use without sacrificing redundancy. But there is a little bit of a performance hit when it comes to restoring, because now it has to calculate based on that algebra what the file that was missing is actually written to disk as. Now, RAID 6, all it is RAID 5 with a second disk in place that is used for writing that what's called a parity bit. It's the second disk that's keeping track of what's written to disk. So in this case, it would look more like 0110, and that's how it would then keep track. So we could lose any two disks in this scenario, and this disk could still have some data, and this disk could figure out what is missing. That's the benefit to RAID 6. So choosing the RAID layout is super important, because when we actually go to install SQL Server, we've got to spread our files out in all the right places. You see, there's performance implications, there's redundancy implications, there's all sorts of cost implications when choosing the right RAID layout and the right hardware that we're going to be using. So in the next nugget, when we install SQL Server, you're going to be seeing that we're going to be spreading some data out across multiple disks. You've got to imagine that we've configured different RAID levels, or maybe the same RAID level, depending on what your choice is, for however our environment is going to be laid out. In this nugget, we covered the different RAID levels that are available to us and the implications when it comes to installing SQL Server. I hope this has been informative for you, and I'd like to thank you for viewing.